In this video we are going to cover about hypersonic planes, their operation, future of hypersonic plane travel and how expensive could that travel be? Hypersonic planes refer to aircraft designed to travel at speeds that exceed Mach 5, which is 5 times the speed of sound, about 6,174 km per hour or 3,836 miles per hour at sea level. The term hypersonic is generally used to describe speeds above Mach 5, with Mach 25, about 30,500 km per hour or 19,000 miles per hour, being the upper limit for most theoretical designs. These planes would represent a massive leap forward in air travel, enabling ultra-fast flights across the globe in a matter of hours. For example, a hypersonic plane could theoretically fly from New York to Tokyo in just about 1.5 hours, compared to the 14 to 16 hours it typically takes today with current commercial jets. How do hypersonic planes work? At hypersonic speeds, several significant physical and engineering challenges come into play, especially related to air resistance, heat generation, and materials that can withstand extreme conditions. Here's how they work. Airframe design. 1. Aerodynamics. Hypersonic aircraft need a highly efficient aerodynamic design to minimize drag and heat. 1. The shape of the aircraft must be extremely streamlined, typically conical or wedge-shaped, to reduce friction with the air at these extreme speeds. 1. This design helps manage the enormous amounts of heat generated. 2. Material selection. Hypersonic speeds cause immense friction with the air, leading to extreme temperatures, often exceeding 1000 degrees Celsius or 1832 degrees Fahrenheit. 2. Special materials, like carbon composites, ceramic tiles, or heat-resistant alloys, are required to withstand these conditions without deteriorating. Propulsion. 1. Scramjets. A major technology for hypersonic flight is the scramjet, supersonic combustion ramjet, a type of air-breathing engine that works by compressing incoming air before igniting it with fuel at supersonic speeds. 1. Scramjets allow planes to operate at hypersonic speeds without needing to carry large amounts of oxidizers, which would be inefficient at such high velocities. 2. Dual-mode ramjet, DMRJ. Some concepts combine ramjet and scramjet technology for efficient operation across different speed regimes, subsonic to hypersonic, enabling smoother transitions between different stages of flight. Thermal management. At hypersonic speeds, heat from air friction can reach extreme levels, so efficient cooling systems are essential. Thermal protection systems, TPS, such as aerogel or ceramic-based coatings, are used to insulate and protect critical components. Flight path and control. Flying at hypersonic speeds involves maintaining stable flight at extreme altitudes and velocities. Hypersonic planes would need advanced autopilot systems and guidance technology to manage flight stability, navigation, and safety during ascent, cruise, and descent. The future of hypersonic flight. The development of hypersonic planes is still in its early stages, with most of the work currently being done by governments and research institutions, especially for military and space applications. However, there are also growing efforts to make hypersonic passenger planes a reality. Here's a look at the future prospects and applications. Military applications. 1. Hypersonic missiles. One of the most immediate applications of hypersonic technology is in military missiles, which could travel at Mach 5+ to reach targets faster than current ballistic missiles, making them harder to intercept. 2. Hypersonic aircraft. Fighter jets or reconnaissance aircraft that can travel at speeds over Mach 5 could potentially revolutionize how air forces conduct missions, offering faster response times and access to global targets. Commercial aviation. 1. Ultra-fast air travel. Commercial passenger flights could shrink dramatically in terms of travel time. 1. A flight from New York to Tokyo could take less than 2 hours instead of 14 to 16 hours. 1. This could revolutionize global travel, especially for business executives, high-value cargo, and time-sensitive services. 2. Point-to-point travel. Hypersonic planes could offer point-to-point services, bypassing the need for layovers or transfers. 2. Imagine flying from London to Sydney in just 3 to 4 hours, or from Los Angeles to Singapore in under 5 hours. Space access. 1. Reusable spaceplanes. Hypersonic technology could be adapted to reusable spaceplanes that can reach orbital altitudes and even travel between planets or moons, significantly reducing the cost and time required for space missions. 1. Technologies like space tourism could be developed, where passengers experience suborbital spaceflights at hypersonic speeds. Tourism and cargo. 1. Beyond passenger travel, Hypersonic planes could provide fast delivery services for high-value, time-sensitive cargo, such as medical supplies, perishable goods, and critical materials. 1. Air freight could be delivered around the world in hours rather than days. How expensive could hypersonic travel be? Hypersonic flight will likely be far more expensive than current air travel, at least in its early stages. Here's why: development and infrastructure. 1. Research and development. Building hypersonic planes requires cutting-edge technology, substantial R&D investment, and overcoming numerous engineering challenges. 1. The early prototypes and first-generation aircraft are likely to be extremely costly. 2. Specialized materials and manufacturing. The high-performance materials needed to construct hypersonic planes, for example, heat-resistant composites, scramjet engines, are expensive and require specialized manufacturing processes. Operating costs. 1. Hypersonic flight will likely consume much more energy than current aircraft, especially due to the extreme propulsion and thermal management needs. 1. This could lead to high operating costs. 2. Maintenance of such advanced technology could also be costly, as components will need to be replaced more frequently due to the extreme stresses of high-speed flight. Ticket prices. 1. In the early years, hypersonic tickets could cost several times more than a typical commercial flight. 1. For example, a transatlantic flight that costs $1,000 to $2,000 on a conventional aircraft might cost tens of thousands of dollars on a hypersonic plane. 2. As the technology matures and becomes more widespread, the cost per seat could gradually decrease, but it will likely remain premium compared to today's commercial airfares for the foreseeable future. Potential for lower cost over time. 1. Economies of scale. If hypersonic planes become more widespread and manufacturing costs drop, the price of tickets could eventually fall. 1. However, it may take decades for hypersonic flight to become accessible to the average passenger. 2. Competition. The emergence of competing technologies, for example, supersonic jets like the Boom supersonic aircraft, might drive prices down faster than expected.